Okay, so this problem, you are doing great. You made the mistake that everybody makes. But you're looking good. Your denominator, perfect. Okay, yeah, 52. Choose five, perfect, or 52 combinations of five. So the numerator is where you made your mistake. Now, the problem's asking for there we go. The problem's looking for two pair. So that would be something like maybe a 2, a 2 and a 2, a 4 and a 4, and then something else, so like a 7. So we're looking for a 2, a 2, a 2, something like a 2, a 2, a 4, a 4, and a 7. That would give us two pairs. Now, the way you did it, here's how you interpret it. The first thing, how you wrote it, is 13 choose 1. So meaning I have 13 types of cards. I have an ace, a 2, a 3, a 4, and so on and so forth. 5, 6, 7, 8, 9, 10, jack, queen, king. Okay, and what you said is out of these 13, I'm going to pick one. That will be my first pair. Maybe pick a 3. Okay, then now that I know it's a 3, the divine power came down, whispered to you, and said, it's a 3. So now you say, okay, what kind of 3? So out of my 3s, I have 4 of them, a 3 of hearts, 3 of diamonds, 3 of clubs, 3 of spades. Now I got to pick 2 of those. So this gives me all the different ways of picking my pair. Now, you repeated it, but you said I've already done 3s, can't do them again, so now I'm going to do it with another number, maybe 5s. Okay, so then 5 of hearts, 5 of diamonds, 5 of clubs, 5 of spades. So now we've got our two pairs, but here's the problem. The way you did it makes order matter. So you said the situation where I pick a 3, then a 5 would be different than if I pick the 5, then the 3s. So, and the reason why is because you said first I'm going to pick one out of my 13, then I'm going to pick one out of my remaining 12. Order's important. It's a permutation. Just by if you go back to the idea of how do you build permutations, picking winners of a race. If there's 17 kids running in a race, first place, second place, third place. How do I do it? Well, out of the 17, I'm going to pick one. Then out of the remaining, I'm going to pick one. Out of the remaining. So do you see how it matches? Okay. So how do we avoid making this a permutation? Well, instead of saying my one pair is a 3, the other one's a 5, pick them both simultaneously. Don't say I'm going to pick one of them here. No. Pick 2. So now I say, okay, my two pairs are going to be a 3 and a 5. Out of my 13, I'm going to pick 2 different types. So then for the first one, pick out of the 4 types of 3s, pick 2 of those. We don't need this anymore. Whoops, excuse me, we don't need that anymore. So now, out of my 4 types of my 5s, pick 2. And then out of the 11 remaining cards, pick 1 type of those. And this is okay because they are, the easiest way to think of it is they're distinguishable. First we took care of the pairs, now we're taking care of our single card. It is not creating a permutation because of because they're distinguishable. They're different events. So whether you do one first or one later, the order, not that the order matters, but it wouldn't matter to you. You would say, okay, here's my 1 card, here's my 7, I'm going to have one of those, and then I get my pairs. Or I can get my 7, then my pairs. It doesn't matter. And you can think of the commutative property of multiplication. It doesn't matter where you do this. It gives you the same number any which way you do it. So anyway, long story short, that's all you had to do to clean up that problem. So out of your 13 types, pick 2. Then 4 choose 2, 4 choose 2, 11 choose 1, 4 choose 1, and you got your problem. You're doing great. Good job.